Hi everyone. Today in this video we are going to derive the EMF equation of a DC generator. EMF means electromotive force which is generated in the generator with the help of Faraday's law of electromagnetic induction principle. So we'll start with few parameters that are related with EMF equation of a DC generator. So first, capital letter P denotes number of poles of the generator. This is our first parameter, and the next parameter is flux phi. So phi is equal to flux produced by each pole in Webers, and the unit for flux is Weber. Next parameter is capital letter N, which is speed of armature or rotor in RPM, revolution per minute. Next parameter is Z, where Z is equal to conductors or total number of conductors armature conductors, total number of armature conductors or total number of conductors. Next parameter is A. A is nothing but number of parallel path, parallel paths in which Z number of conductors are divided. So Z number of conductors are divided, right? So here parallel path means number of path that a current can flow between the generator terminals is known as parallel path, right? So there are two category of winding can be wounded on DC armature slots. One is lap winding. The another one is wave winding. Here in lap type of winding, if the generator armature conductors are wounded with the help of lap winding, then in this category number of parallel path is equal to number of poles. In wave winding category, number of parallel path is equal to 2 always. So these are the two major points need to be considered while deriving while designing the DC generator number of conductors, that is with respect to number of parallel path. In lap winding, A is equal to P means number of parallel path will be always equal to number of poles in the generator. If it is number of poles is 2, then parallel path of A is equal to 2. If number of poles P is equal to 4 means then A is equal to 4, right? But in wave winding configuration or in that category, if wave winding is wounded on armature conductors, then or if wave winding category is applied for armature conductors to wound on the rotor, then number of parallel path A is equal to 2 always. So this is the parameter that we are going to consider for our derivation. So we already know that as per Faraday's law of electromagnetic induction, Faraday's law of electromagnetic induction, as per this principle, average EMF induced, average EMF induced in the generator E is equal to d phi divided by dt. Here phi represents flux and t represents time, right? So the parameter flux will always varies with respect to time t, right? The flux phi occur due to field winding or main winding and due to armature winding, right? So as per the Faraday's law of electromagnetic induction, average EMF will be induced due to linkages of flux between field winding and armature winding, and the average EMF induced in each armature conductor, induced in each armature conductor will be E is equal to d phi by dt, where d is the rate of change of d phi by dt is the rate of change of cutting flux, right? As I already told, flux occur due to field winding, energization of field winding or magnetization of field winding and armature winding, right? So we have used d phi divided by dt, and we have used this d term because flux will change with respect to time. So to denote the rate of change, we have used d phi by dt here, right? So next, now we are going to consider one revolution of rotor. So for one revolution of rotor, conductor will cut the total flux produced by all poles. So for one revolution of rotor, conductor will cut total flux produced by all the poles. So it can be represented as phi into P. So number of poles, if we increase the number of poles, then flux lines will be increased. So if the P is equal to 2, then if number of poles P is equal to 2, then there will be equivalent amount of flux lines will be produced in the machine. If P is equal to 4, then there will be equivalent amount of flux produced with respect to number of poles, right? So if you increase the number of poles, the flux lines will also increases, right? Now, while time required to complete one revolution is time required to complete one revolution is 60 by n seconds, because speed is represented by or represented in RPM, revolution per minute. So for to complete one complete revolution, the rotor takes 60 by n seconds. This is the time period, and for one revolution of rotor, the product phi into phi will be the flux, total flux produced by all the poles. Now we are going to rate these two terms. Now E will become E is equal to phi P into n divided by 60. Phi P into n, because phi into P divided by we can write E is equal to, I am going to substitute, let us assume this is equation number 1 and this is equation number 2. Now, and this will be equation number 3. So I am going to substitute equation 2 and 3 in 1, right? So 5p divided by 60 into n. Now the n will go to the numerator, we will get this expression. So E is equal to 5p into n divided by 60. This is equation number 4, right? So now we have found the EMF for one revolution, one complete revolution with respect to one conductor, one armature conductor. Now there are Z number of conductors in A parallel paths, right? So we need to consider Z and A in this expression. So the expression will become, now we have the expression as E is equal to 5p into n divided by 60, right? Now for Z conductors, with A parallel paths, so as I already told, parallel path is nothing but number of path that in a machine that a current can flow between the generator terminals, right? So hence the final expression will be Z by A number of conductors, Z by A number of conductors. So for this, now we are going to write the EMF equation E is equal to 5p n divided by 60 into Z by A. We are considering this is equation number 4 from previous slide. So this equation number 4 can be written as E is equal to 5p n divided by 60 into Z by A, where Z is number of conductors with respect to number of parallel path, right? So now we can also write E as capital letter E, I mean EMF, capital letter EMF can be represented capital letter E. E is equal to 5p nz divided by 60A. So this is the final expression for generated EMF or EMF equation of DC generator. This is equation number 6. This can be also expressed as E suffix G. G represents generated EMF 5p nz divided by 60A, the same, right? We can also represent the EMF equation like this also, right? So now there are two type of windings. One is lap winding, another one is wave winding. So with respect to lap winding, the EMF equation will become, for lap winding, we have seen in previous first slide, A is equal to P, right? Number of parallel paths equal to number of poles. So substituting this in equation number, substitute A is equal to P in equation number 6. So we will get Eg is equal to 5, instead of P I am substituting A here because A is equal to P in lap winding. So 5A nz divided by 60A, where A will be cancelled and the remaining we will have Eg is equal to 5 nz divided by 60. So this is the generated EMF equation or expression for lap winding category of DC generator. Now for wave winding category, so if the armature conductors are wounded under wave winding category, then number of parallel path A is equal to 2 always. Number of parallel path is equal to 2 always if this wave winding category. Now substitute A is equal to 2 in equation 6. So Eg will become, Eg is equal to 5 p nz divided by 60 into A is equal to 2. So I am substituting 2 instead of A. So I will get Eg is equal to 5PNZ divided by 120. So this is the EMF equation of or generated EMF equation for DC generator under wave winding category, right? So to conclude for lap winding and this is wave winding, lap winding, wave winding. Lap winding can be used for low voltage applications and wave winding can be used for high voltage applications. Lap winding can be used for low voltage applications and this is for high voltage applications. This is first point. And second point, due to the low voltage application, the current will be above 500 amps. So it can be used for capacity above 500 amps applications, right? And here wave winding category generators can be used for below 500 amps applications ratings, right? So these are the two major conclusions from wave winding and lap winding category of DC generator, right? So I hope the derivation is clear for you. We will meet in next video. Thank you.